Russia's multi-billion-dollar war tech is being outmatched by a team of weekend engineers. Not defense giants, not government labs. Just 150 volunteers with laptops and soldering irons, and they've made some of the Kremlin's most expensive battlefield tech obsolete. While NATO debated paperwork and red lines, these engineers moved fast. Faster than military procurement, faster than Russia could adapt, and the results are staggering. Jammers that blind drones, target trackers built from scratch, and anti-tank tools designed, tested, and deployed in weeks. They call themselves Defense Tech for Ukraine, and they've reshaped the battlefield from their basements and garages. This is what happens when brilliant engineers meet wartime urgency, and why Russia's war machine is suddenly looking very outdated. Like many Ukrainian efforts that we've seen over the past 3 years and 4 months, DTU traces its beginning to the initial days of the crisis. As Ukraine's defenders scrambled to shore up the country's lackluster military capabilities when Russia's full-scale invasion started in February 2022, a handful of pro-Ukrainian veterans, engineers, and foreign tech allies realized crowdfunding a few drones wouldn't cut it. When Russia launched its invasion expecting to crush Ukraine within days, world leaders held emergency meetings. Major defense contractors from the US and Europe submitted proposals for long-term contracts, most of which wouldn't really matter if Ukraine wouldn't survive as an independent country in the immediate future. But a small group of engineers, veterans, and tech professionals from across North America and Europe was already building something completely different. What makes DTU revolutionary is the entire operational framework and paradigm that drives Ukrainian innovation. There's no boardroom to clog up precious time in meetings, agendas, and status updates. The team makes just 6 weekly conference calls, split between English and Ukrainian teams, where developers meet directly with end users, which are soldiers testing their inventions under fire. Think about that for a moment. When traditional defense companies go through layers of bureaucracy and committee reviews, procurement processes can take years. Furthermore, the testing is done in a controlled environment with no real knowledge of a theoretical opponent's tactics or capabilities. In contrast, DTU engineers are getting real-time feedback from soldiers actively using their inventions in combat. As co-founder Carl Larsen noted, the pressure is what keeps the entire team centered on meeting ever-stringent deadlines. At one meeting, a member warned that if Ukraine didn't move fast enough, Russia would field the same idea first, which would lead to losses of both lives and equipment. Leading this tech revolution are 2 Americans who couldn't be more different but share an unshakable commitment to Ukraine's survival. Carl Larsen, co-founder and executive director of DTU, is a former soldier in Ukraine's International Legion who served on the front lines for the first few months of the war. Larsen is also a US Army veteran who served in Iraq and went on to conduct multiple interviews retelling his time on the Ukrainian front line. In particular, he has seen firsthand how effective drones can be as killing machines and how hard they are to stop, but also the psychological strain troops must deal with. He used those experiences and his crowdfunding expertise to help build DTU from a small volunteer organization to a multi-national effort. Then there's Jonathan Lippert, DTU's president and an entrepreneur who represents the civilian tech talent that has rallied to Ukraine's cause. When the full-scale invasion happened, I was mostly horrified and demoralized, Lippert told LSM, the Latvian public media. Then I saw someone on social media volunteering to bring in body armor on their own initiative, and I thought to myself, wow, good on them. This was all the motivation Lippert needed to bring his expertise to Ukraine, trying to help the country defend itself against a much larger and seemingly more prepared opponent. Together, Larsen and Lippert built a platform other volunteers could use to pitch and rehash their ideas for remaking and updating Ukraine's military technology to keep up or leapfrog over Russia's advancements. Of course, as important as the people are in DTU, it's the results and innovations that truly matter, and the group has been responsible for an admirable amount of them. One of the key innovations was the adaptation of first-person view drone designs. In particular, the change revolved around the way the drone connects to the operator. Instead of using a wireless network that relies on sending out and receiving signals from the exact device the operator is using, DTU's drones were among the first to utilize fiber optics for communication. The concept came from Troy Smothers, a US Marine veteran and founder of the Drone Reaper initiative. In turn, Smothers took the concept from Russia, as Forbes covered the news report of Russian fiber optic drones being spotted in Ukraine in March 2024. Smothers devised his own version of fiber spooling drones within 3 months and came to Ukraine. Think about that timeline. It took only 3 months from concept to battlefield deployment. Traditional defense procurement takes 3 years minimum if you're lucky and everything goes your way during the endless bureaucracy and testing requirements. In Ukraine, Smothers met with representatives of various defense companies and organizations, from private startups to state-funded military enterprises like Ukroboronprom and Brave One. I showed them how they could attach a small accessory kit and turn their UAV into a fiber optic drone for less than $200, said the volunteer in his own interview with Forbes in late 2024. But here's the kicker. With his solo effort, Smothers thought he had reduced the cost of his development as much as possible. When he came to Ukraine and the military and the DTU got their hands on the prototype, they managed to make those same adaptations at an even lower cost. The DTU used its decentralized system and rapid testing iterations on world applications to the limit, refining the drone at a rate traditional military-industrial companies can only dream about. And then DTU made a decision that would reshape modern warfare. It gave away the designs and schematics for the fiber optic drone to the Ukrainian military, who had free rein to disseminate it to its other suppliers. Before the end of 2024, the same fiber optic system will be spotted flying not just over Ukraine, but for Ukraine. And by open sourcing the design and proving it in combat, DTU allowed the drone to transcend its initial purpose. On Russia's side, the fiber optic drones were primarily used for precision strikes and surveillance missions. For Ukraine, drones were also built for resupply missions in places too deadly for manned vehicles to push through enemy forces. At this point, you might wonder what makes a fiber optic drone so special. For that, we need to refer back to the vital changes in its communication system. As mentioned, a traditional FPV drone is networked to send and receive wireless signals everywhere around it. The operator's control console picks up the signal and translates it into a communication stream. The console's signals, which come at a specific frequency, are also translated by the drone in coordinates and commands, helping it navigate and perform the mission it was built to do. But wireless signals don't discriminate between what or who sent the signal and from where. If Russia is able to brute force the signal's signature or prevent the console's signal from reaching the drone, it can completely blind and ground the drone, rendering it harmless. Furthermore, those signals can be detected, giving the enemy a clear indicator of the drone's position and possibly even the location of the operator, as their console sends out complementary signals. With drones being purpose-built to deploy ordnances or carry cameras, they also have practically no defensive systems to work with and can be easily destroyed by gunfire or even other drones. So between the first mentions of drones on the battlefield in June 2022 and the reveals of fiber optic drones by Russian forces in March 2024, both sides of the conflict were trying to one-up each other in drone countermeasures by utilizing the fact drones were visible if you could surveil the radio spectrum. Fiber optics drones completely changed the game. Since the communication is done via a conductive cable, there's no signal to ping off the drone and notify the enemy of its location. Fiber optics also have the handy feature of channeling the signal at nearly the speed of light with practically negligible degradation at distances that correspond to the drone's operational range and weight limitations to carry the spool of fiber. And thanks to the quick deployment time, Ukraine was only slightly lagging behind Russia in deploying the fiber optic drone to the front lines. Within months, the ground near the front lines were completely covered in shed fiber optic cables from drones that launched their missions and never returned. The impact of these drones is devastating for both countries. Anton Moholevets, the chief engineer of one of the many companies that develop and produce drones, has commented that this drone is completely invisible in the radar spectrum. No electronic warfare system can determine its launch site or operator. This makes it much more capable of avoiding built-in countermeasures and likely to get to its destination without being shot down. Ukraine has quickly adopted fiber optic drones and incorporated it into its drone production capabilities. One of the flagship models of the drone developed by Moholevets' company is equipped with a 12-mile cable, allowing it to fly for 20 minutes at a speed of 37 miles per hour, equipped with a 20-kilometer cable, while carrying an explosive payload of up to 12 pounds. Some Ukrainian units have pushed the technology even further, as newer models push the range to 25 miles, potentially capable of targeting deep defense positions, including long-range artillery, MLRS, and medium-range air defense systems. It should be noted that Russia is still largely credited as being the progenitor of the fiber optics drones for military use, and its models are still outperforming Ukraine's counterparts, something that the DTU is working tirelessly to remedy. A key point in Russia's corner is its platform's high reliability, as Russian drones reportedly have an 80% accuracy rate at a distance of 12 miles. By comparison, Ukraine only manages 50% accuracy at 5 miles, making their drones much more niche in application. The difference is attributed to Russia's greater access to contemporary technology, particularly to signal repeaters and high-quality digital cameras on board the drone, which allow the operator a greater level of control and combat surveillance. Both of these technologies are something that likely stems from China, as the latter has consistently exported vital drone-related technology and parts to Russia throughout the war. On the flip side, DTU has also tried to make its drones easier to operate and more adaptable. For example, Ukraine uses thinner and lighter fiber optic cables, which help the drone shed some weight. Russia's most successful drone, the Kinaz Vandal, also known as Prince Vandal, carries a long cable that weighs as much as 5 pounds per 6.2 miles of cable, limiting the drone's payload and maneuverability. Despite that, a vandal has been able to destroy a HIMARS system, which was one of only 4 complete losses of this vaunted platform. If DTU can manage to accomplish the same by reducing the weight of its devices to improve its range and speed, it can deliver the same devastating punch to Russian tanks and artillery systems that dare move near the front line. Additionally, DTU has printed the links to drone instruction manuals to sun visors and attached them to digital scanners, allowing soldiers to still have access to the manual when the paper instructions inevitably get lost in the chaos of the front line. This is the level of on-the-feet thinking that made DTU stand out in the first place, as it directly helps soldiers resolve small but meaningful issues with their equipment. And while Russia has the edge in fiber-optic drone performance, Ukraine seems to have the advantage in the rest of the drone industry. Ukraine has been steadily building up its long-range drone capability for the past 3 years. In that time, the famed Bayraktar TB2 drone from Turkey went from one of the most notable pieces of Ukraine's drone arsenal to a piece of scrap, as multiple iterations of domestic drones outpaced Bayraktar's specs and Russian countermeasures caught up. When faced with functionally invisible FPV drones on the front line, Ukraine turned to those same long-range systems for assistance. Instead of trying to hunt the drones, Ukraine simply struck Russia's only fiber optics production facility in April. The manufacturing plant is located over 400 miles from the Russia-Ukraine border and was responsible for roughly 25% of the country's fiber optics market, with the attack likely temporarily stopping all production. This is a potential 25% cut in Russia's ability to procure fiber optics drones, with the most likely scenario being that the cost of those drones will skyrocket to a point where Russia won't be able to make them at scale. However, fiber optic drones are just the beginning. DTU has become a relentless innovation machine, churning out solutions faster than Russia can adapt. DTU-backed projects range from drone-mounted net guns to vertical takeoff bombers and low-cost radar systems. They're also developing an RF detection device, an acoustic system now being trialed in combat, and a sub-$10,000 radar urgently needed to spot Russia's newest fiber-optic drones. The pace and scope of DTU's innovations is breathtaking. Lippert suggested that the first 3 prototypes for drone-mounted devices would start field tests in June. One of their creative solutions is something straight out of a video game: the ICLO drone-mounted shotgun system. It's a flying, recoilless gun designed specifically to take down enemy drones. Essentially, instead of carrying ordnance, a drone would use a loaded gun with a remotely operated trigger. When the operator spots an enemy drone, all they have to do is sneak up on it from above and send the command to fire. It's cheap, effective, and exactly the kind of unconventional thinking that traditional defense contractors would never consider or be able to implement in timeframes necessary for the product to get from prototype to field testing in months and make a difference on an active battlefield. The previews of shotgun drones sporting a similar system have been shown by the Ukrainian military's Telegram channel. If the systems are analogous, this means that DTU is closely following independent developments from across Ukrainian drone manufacturers and collating them into open-source systems. This collation and outsourcing is perhaps the biggest reason why DTU has managed to seep into so many parts of Ukraine's drone industry. While Russia's manufacturing and research are heavily centralized, Ukraine has spread its efforts between state-supported and independent companies as well as volunteers. This broad ecosystem drives not only innovation, but healthy competition and improvement. As such, the DTU partnered with Brave One, the Ukrainian government's official defense tech coordination platform, and works alongside groups like Kyiv Defenders, who are responsible for drone training and support for Ukraine's strike teams. When all these companies pool their efforts, this small innovation platform can reach soldiers on the front line in record time. The decentralization of military innovation has made waves in NATO's military analysis, research and development circles, as DTU basically proved that the current model of defense innovation is broken. Consider the numbers. It took just 150 DTU volunteers working weekends and evenings to deliver battlefield-changing innovations in weeks, all the while using budgets that amount to pocket change compared to traditional defense contracts. Meanwhile, programs like the F-35 took decades and cost over $1.7 trillion to develop, and that's actually one of the US military-industrial complex's success stories. Take the Zumwalt-class destroyers, which were supposed to complement and eventually supplant the existing Arleigh Burke models. Instead of the planned 32 ships, the US manufactured only 3 as development costs surged and triggered a government provision that stopped further production. The destroyers ended up being one of the US's most expensive military programs at a staggering $7.5 billion per ship, nearly 3 times the cost of the Virginia-class submarine before the payload module upgrades. DTU also offers Western innovators and defense planners a glimpse of the future. a wartime innovation pipeline powered not by national labs but by networks of passionate individuals working outside of hierarchies. The implications are staggering. If a volunteer organization can outpace NATO's entire defense industrial complex, what does that say about how the entire world has been approaching military innovation? Ukraine has managed to cobble together a working air force, navy, and army by using drones as key pieces across sectors. Traditional, and more importantly expensive, systems like the donated Patriots, HIMARS, and Javelins can no longer keep up with the scale of the attacks Russia is launching at Ukraine. If they did, they would basically bankrupt the US through missile manufacturing. After all, Russia launched roughly 35,000 drones and missiles in the span of 26 months, from September 2022 to December 24. In 2025, this ramped up to an average of 260 drones per day for a 6-month estimate of over 46,000 drones thrown at Ukraine. Lockheed Martin produces 42 Patriot missiles and 200 Javelins per month, with the latter actually being below the company's target. These weapons are simply way too limited by their cost and production times to be used on cheap drones. But the most telling sign of DTU's impact is that Russia went from being the innovator to possibly becoming the copycat. On the Russian side, a combination of creative volunteer engineers and ready access to Chinese tech gave the aggressor an early lead, which they exploited on the battlefield while Ukrainian production was still ramping up. Alexei Chadayev, a political scientist turned volunteer, founded the Ushkunik military tech accelerator. The project started with interceptor drones but ultimately produced the Kinaz Vandal, fiber optic FPV, and possibly other models. This indicates a semi-organized innovation drive within Russia to leap ahead in drone tech. However, what Russia is doing amounts to centralizing what DTU has proven works best when decentralized. Furthermore, it's fairly obvious that one of the main reasons Russia's initial strategy in Ukraine failed in 2022 was precisely due to its rigid, centralized command structure. Applying that same concept to drone production is unlikely to yield different results. Therefore, the more obvious solution is that Russia devolves from iterating on its own designs to brute-forcing Ukrainian developments and using a larger economy strategy to eke out a positive result for itself. DTU's message and lesson to the world is clear. The future of warfare belongs to those who can innovate fastest, not those who can spend the most. And right now, that future is being written by volunteers working from their garages, basements, and weekend workshops, working on one life-saving innovation at a time. But fiber optics drones are far from the only ones making a difference on the battlefield. You can check out our comprehensive coverage of Ukraine's Baba Yaga drones in this video. And remember to subscribe to The Military Show for daily news on the war in Ukraine and in-depth analyses on the future of warfare and global geopolitics.